Andrew Ng, one of the well-respected godfathers of AI, co-founder of Google Brain, came out this week and said, AI agents are the biggest thing happening this year, more important than GPT-5, and I 100% agree. The most popular example of an AI agent is ChatGPT, and contrary to popular opinion or belief, it's not just an LLM. It can actually use tools. So that's how it looks up the web, how it creates pictures, how it's able to use a math solver to solve numeric problems. And it does all of this by using an AI agent implementation. But it's a generalist. Narrow down the scope of what you want it to do, and it can automate whole job categories. In this video, I'm going to explain what an AI agent is, how to build one that can automate a job, and how that's likely to change the world of business. Okay, so what is an AI agent? An AI agent is a digital worker that knows how to do a job and is connected to the tools it needs to do the job. Simple. So take an example. This is our AI agent for customer support with Shopify. It can handle order tracking queries and other types of queries, and it's hooked up to the back end. So if you're looking over here, you can see that someone's come in, they can say, hey, where's my order? It's been a week. It can come back, it can say, look, it's in transit, it's coming out in this thing, it's being delivered by these people, which allows it to do a really useful thing for the customer. So not only is it just sort of responding, it's looking into the real world, it's understanding where their package is, it's giving them a real answer, it's solving a real problem for them. And to do this, it's hooked up to the back end, it's hooked up to the order management system. You can also answer queries about discounts by using knowledge bases and all this sort of stuff. So it's able to automate 80% of the queries, save 88% of the costs. Awesome. So how do we do this? Well, actually, there's a lot of deceptive complexity to AI agents, especially if you've just played around with an LLM. So if we look at this, you can just go to ChatGPT, anybody can do it. You can say, hey, can you role play as a customer support agent for the Edit London and operating as a chatbot embedded in their website so it knows the context of what it's doing. And then say, the user asks, can I get a discount code? And here we see it gives a lovely reply. It's of course, we're happy to hear that you're interested in shopping with Edit London. Currently, we're offering a 10% discount for new customers. Simply use new 10, blah, blah, blah. That is a response that you could imagine, any chatbot agent giving. The only problem is that it's wrong. It's made up. I mean, the Edit London, there's no code new 10. There's no 10% discount. So, it's just made stuff up. And this is sort of known as hallucinating. This is like the general term that we've come up with. But really it's just that the LLM had no knowledge. It used the next most likely words to try to make a plausible answer, and that's what it came up with. And so it's probably a good generalist idea of what people do, but we want to make it give the right answer for our business to make it useful in our context. So what we can do is a technique known as prompt injection. So here what we do is we take the same sort of role play idea, but we add an FAQ into the prompt. So we actually add the question, can you give me a discount? And we give the answer, the real answer that we want, which is basically customers can get a £15 discount if they sign up to the newsletter, and repeat customers can join the loyalty scheme to earn points that get converted into discounts. So then basically we say, hey, the user asked the same question, and now we see that it gives out a great answer. So it's basically saying, yeah, you can get this discount, blah, blah, blah. Perfect, right? So this is good. Not quite. So the challenge that we have is like in the real world, knowledge bases are big. People have thousands of documents in a lot of cases. There's thousands and thousands of pages. There's thousands of products. There's all of this knowledge that needs to go in. It's hard to put all of that into a chatbot prompt. We'll just run out of space or it won't work on it reliably. So what we can do is we can use this technique called retrieval augmented generation. And I'm not going to go into the full detail of it, so we're just doing a kind of a simple outline of it here. But basically, the user asks a question, in this case, can I have a discount? So then it needs to go off and needs to look up all of the potential documents. So to do this, we basically transform the question into a vector. The vector is basically encapsulates a lot of the semantics into a vector space. And so what we're able to do is we're able to find a vector that's sort of got the most similar sort of direction when we do the same sort of process of embedding the document, all the individual documents, and then we can say, okay, this is the closest match. So it's most likely going to be around discounts, have all this information. So then once we inject that into the prompt, Hopefully we take the sort of, in this example, 10 million documents, reduce them down to the 4 closest matches that hopefully one of them is going to have the right answer, and then we insert that along with the prompt, and then the LLM call has all of that information right in the reply, and it's able to give a really good response. So then we get that, new customers get a £15 discount and all this sort of stuff. So this is a fairly well-known technique. There's a lot of subtlety to make it actually really work well. But like I said, that's a topic for another video. So once we have all that, though, the challenge is that when we look at a real job, it's not just about informational retrieval. So if we're just taking something as simple as a train station attendant, they might be involved in the selling of tickets. They might have to help people figure out how to get places. They might have to help people find amenities in the station. They might have to operate lost and found. So there's some dynamic databases, there's different backends they might want to call into. There's a lot of different things they have to do that's over and above just this information, so we'd still end up with like a big old prompt. So yeah, so basically if we're looking at sort of how we might break this down, get an idea of it, we end up with a job that sort of combines all these sort of common sense abilities that we use the LLM for. So common sense, reasoning, communication, creativity, and general knowledge, that's all coming from the base LLM. But then what we need to do is for the different tasks or things that we need them to do, we need to have the specialized knowledge for the task, we need to have the process it needs to perform for that task, and then we also need to have the tools that it needs. So it doesn't need to use a back end, it doesn't need to be able to call out to the web. What does it need to be able to do to accomplish that job? And so if we have a whole load of different skills for all the different things it needs to do, boom, we've got something that can do real work. Sounds awesome, right? Well, we can try just cramming it all into a prompt, but basically size isn't the limiting factor. If we look at new models like Gemini 1.5, we've got 1 million tokens. So, you can describe a lot of people's jobs in 1 million tokens, but it still doesn't really work out that well. And actually, the challenge that we have is the train of thought for the LLM. So more technically, it's called task coherence. So if we have too many instructions, the LLM goes off the track and doesn't respond to tasks. And in terms of outsourcing a real job to AI, this is probably the biggest limiting factor. So let's dive into this in a little bit more detail. So here we can see that I've got a simple example of a train line where we're saying there's, stop F, stop A, and stop E on one line, and then there's stop S, stop A, and stop L on a second train line. It takes 1 minute to get from one station to the next. So, stop F to stop A is 1 minute. And then we're saying, what's the fastest way from stop F to stop L? And basically, we can see the fastest way is to go from stop F to stop A, and from stop A to stop L. So 2 minutes. Perfect. It gets a great answer, lovely answer, not very complex. It does a great job. So now here we're looking at an example where we give it too many instructions. So here we up the complexity a little bit. We've got 8 stations in the first line. We've got 6 stations on the second train line. We've got a third train line with 4 stations, and then there's like stop A connecting to stop A, and there's stop G and stop G and Q and Q and Q. So there's a lot more connections, a lot more complexity. You can see that we've not come anywhere near the 1 million token limit, or any of this sort of stuff. So, it's not about how much you can squash in the prompt. It's about how much the AI is able to do with what's there. But we can see it gets it wrong. So it's actually kind of suggested that we go straight to stop Q, and then from stop Q we transfer over here and we go to stop L. It would actually, the whole journey would take 7 minutes, but it sort of thought that it would take 8 minutes. And actually the shortest journey is actually to go from stop F to stop G to stop Q to stop L. So it's just, the wrong amount of time, wrong path, it just hasn't managed to track the reasoning. But if we break this down, so we basically look at the first train line and the second train line together, and we can then see, okay, now it's actually figured out that the fastest way here is to change to stop A and go to stop L, which is exactly right, and it will take 6 minutes. That's great. And then we look at the next train lines. We say, okay, well, how about the first train line and the third train line? We just give it a little bit more information about the next train, and bam, it gets that one right too. So we can see that by breaking down the problem into one line and one train, 2 train lines at a time, one set and then another set, it was able to get both questions right. Even though these are like a lot more complex than that first example, but just not quite as complex as that middle example. So the trick here is really that we need to break a task down into really small jobs that are bite-sized and doable via current LLMs. So when we're creating an AI task, the trick is to limit the scope with limited instructions, and then we add the relevant tools and specialized knowledges and processes for that task. So we kind of, if we're looking at a train timetable task, we might have an API that has the REST API to be able to go and get the real train times. We might have a knowledge base of passenger alerts, what's going on in different stations, are there any issues with the service in general, and then a process which would say, ask them where they're traveling to, tell them how best to get there, inform them of any relevant passenger alerts, answer any related questions. So it's just kind of giving the AI a general guide about what to do if the person isn't, leading the dance. And in this way, we create a nice, simple, self-contained AI task. And one of the things that we can do is actually we can start to put loads of prompts together. There are a lot of different ways to do, data extraction. So if you're using the OpenAI APIs, you might just use a tool call directly. But, this is just kind of giving a more generalist example. So we might say, okay, well, I might have one prompt that extracts the depart location. I can then have a guardrail, which means that I take that departed location that comes out and then look up the system to make sure that's really a train line stop that we support, because I'm going to have a fixed list of those, so I can sort of validate that with code. And then I can basically have another one which is extracting the arrival location, call out the same guardrail. We can basically extract any time information saying, hey, I need to do that in a week's time, in 2 weeks' time. You can then say, okay, is it a valid time? Is it in the future? Then you can do your API call to basically say, what is the fastest route? Then you can take the response of the API call, take the other responses, and basically get it to create a valid reply for the customer. So, it sounds great. And then actually at the end there, we can put a little sort of reflection prompt like, did it make the correct use of the information, or just, is this right? Or any sort of self-reflection. It's actually an interesting thing that's come out of LLMs, where before in some fields like food critics, there was a debate like who's got more, what is more elite, what is the best skill? And LLMs settled the debate. It is easier to be a critic than to be a creator. So LLMs are actually better at critiquing their own outputs than they are at creating the outputs in the first place. So even if the same LLM just generated the output, it might actually go back and say, oh, actually that's a bit wrong, I can fix it, I can do better. So it's really useful to use that in our guardrails as well. And if we put all this together now, we kind of end up with the AI agent frameworks. This is KorticalChat AI agent framework. And what we're doing here is we're taking these tasks that we've created. So we've got this sort of idea of a task, which is made up of these prompt chains with guardrails and tools and being able to use RAG vector stores and REST APIs and databases to look at various informations and do different parts of the job. And then we have an AI routing layer on top of that. So we have, let's say, task 1, task 2, task 3. They might be train time with table, lost and found, ticket sales. And then, we use the AI routing layer to sort of look at, with the question that's come in, where should we distribute that task to? So when someone chats with it, it feels just like they're talking to any bot that's maybe just using an LLM. So it feels like they're just kind of getting that response. But behind the scenes, it's able to interact with those tools, call multiple prompts, all of this sort of stuff. So in that way, we kind of say it's a bit like an iceberg. It's sort of, the chat interface looks the same, and then underneath that is all of this complexity, which allows us to go from something which seems right most of the time to something which is actually right, which we've got a lot of guardrails to ensure the correctness of the outputs, which we have a lot of control over the processes and the way that it works. So I kind of use the iceberg diagram, and part of this here is because when we go back to that deceptive complexity of AI agents and of making really good chat services, because it's so easy to ask ChatGPT to role play as a given thing or to give a reasonable reply that seems correct in most circumstances, it's just kind of surprising that you have to do all of this to get it to be really reliable all the time. So it's kind of like, a bit of an iceberg where there's a lot of depth and complexity underneath the hood. But the really cool thing about this as well is that AI agents are composable. So once you put a lot of effort into getting a specific task right or getting a specific agent right, you can then basically say, okay, so actually I'm going to insert my feedback agent into the middle of my other agent, and you can just sort of use these tasks and put them, compose them top. So it's turtles all the way down, essentially. And in this way, you can kind of quite rapidly evolve and build new agents for new problems. So, hopefully right now you're going, oh my God, okay, unless you were thinking, I actually know all of this stuff about AI agents, you've just seen that we can basically make AI agents do real work, do reasoning on real jobs, use tools in different contexts to, automate whole bits of labor that we currently use, people to do. So using the AI agent framework, we can make current LLMs, stress on current, we don't need anything new, automate complex jobs that currently need real humans. And it works. I think that's the thing, is it really works. So we're doing this right now, with the Shopify. We're also doing this with tax accounting with one of the big 4 tax companies with their R&D bots, basically being able to, process the R&D claims. With HS2, it's the health and safety reporting. It's basically being able to analyze loads of the historical information on health and safety, pull out best practices, build reports, all these things that were currently, painful for people to do, and now we can get an AI to do them, super effectively. So one of the big things, though, is about managing costs. So I think the thing is like, as you can see, once you start doing one of these chains of prompts and you're bringing all these things together, calling big LLMs like GPT-4 via LLM, it's just not that cheap. It's very easy to go from something where you chained 8 calls together and suddenly, it's £1 for one reply, which can easily make a lot of use cases not that viable. So, the first thing that probably jumps into people's mind is like, oh, well, if we've got all that sort of scale, then maybe the next thing we do is we host our own LLM. But that's challenging too. So if we look at sort of Falcon 180 billion, one of the better open source models, we need 8 A100 80 gigabyte GPUs to actually run it at a decent click. So that's kind of like a 200K investment in GPU cards to be able to run it at a decent click, and that's sort of beyond if we have to scale it up for other problems. So, it's not always that great to do that investment. And also then you're looking at potentially in a couple of years' time having to replace that with the next latest and greatest thing as we get the H100s and all that sort of stuff. So that can make the sort of self-hosting challenge. So the way that we really approach this is, it is hard to make a great solution. It's even hard to make a great solution that's cheaper than people. But the trick that we found is basically to use the right model for the right task. So you really want to work on those tasks with those individual prompts, and you want to basically make sure that your sort of, your AI routing, your guardrails, all these things are using the cheapest model that gives a good level of performance, and then we save the big LLMs for the complex stuff. And basically we can, fine tune the smaller, cheaper models. We can use, custom built models that can save a lot on the cost too. So one example of that is actually, we were trying to do the sentiment analysis because we need to be able to figure out, is the customer happy, is the customer not happy, rather than using a GPT-4 call, which will end up super expensive over time. We were able to just build a custom model in the Cortical platform, and it's roughly 300 times cheaper to run. So by being smart about are we fine-tuning the models, are we using GPT-3 where it makes sense, are we even using sort of Curie and Babbage and all that sort of stuff, we can really manage the cost and bring that down, and then realize those savings. So that sort of optimization step does make it a bit harder than just creating the original solution, but it's well worth it to get the savings. And if we get it right, the savings are big. So in the Outer London, it's saving 88% in costs by using a KorticalChat AI agent, and that agent is handling 80% of the support requests with no human involvement. So, like we say, you can win big if you get it right. It's just about getting all those tasks set up, get the back end set up, get all the right prompts, get all of the right models for all the right prompts, and then you too can save. Okay, so basically the future. So where is this leading to? It's cool that we can make the stuff, but where is it going? So there's still some unknown magical step to get from what we've currently got to a real life boy, or AI with wants and dreams of its own that basically wakes up in the morning and thinks, man, I don't want to work today, or whatever it's going to think. So, LLMs are a technological marvel, but they're not really that much more complex than an automata, or any more alive than an automata. So automata, if you don't know, they're these wonderful clockwork creations that people were doing back at the turn, the turn of the sort of 19th century or 18th century. And what they're doing is they're building these lovely clockwork creations. They thought if they could just make them lifelike enough that maybe with some unknown, but like slight leap, they would just kind of get up by themselves and start walking around and be smart, intelligent, basically kind of like artificial people. Now, given what we know now, that seems like a really quaint idea. But at the same time, we're here with networks, which basically are a chain of weights going forward. Like it's a series of multiplications, and people are asking the same questions that we were asking back then. It's like a calculator. It's input in, press enter, get input out. So it's not likely to wake up until we do more steps. The clear and present danger from AI is not AI deciding to take over the world, but that is where the conversation is. I mean, we had the whole AI Safety Summit, which is imagining a lot of those risks. And it's not to say that long term there aren't some of those risks, but the really much more immediate, risk that is happening right now, is unfortunately the impact on jobs. But it makes for less sexy headlines than the existential threat. So it's kind of being largely ignored, and we're not really as countries or people or our governments aren't really preparing for it. So we're going to kind of sleepwalk into it. So the best thing we can do in the meantime is ride the wave, so no one wants to get run over it. Might as well get on it. And it takes a while how to figure out how to commercialize a new technology effectively. So, I mean, everybody remembers when apps came out, somebody picked up their phone and was drinking a beer from it. And it was hard at that time to just sort of see that and imagine, like Uber is going to be a killer app. Deliveroo is going to be a killer app, being able to hook into a fitness program or da-da-da-da. Like all these things weren't immediately obvious about how we would, monetize or use, or what the killer apps for these devices were, because it's really the instantaneous transfer of information is the killer thing about the web, and it just takes a while to figure out how to use that. And with AI, it's going to take a while to figure out all the new crazy awesome things that we can do with this sort of technology at our fingertips. But what we do know is people are expensive. Typically 40% of a business's costs are people. And it's really easy to see what those people do and to basically, automate it, LLMs promise unlimited cheap thought labor. So there's some debate here where basically some people think, but it's not thinking the way that people think, or it's not doing these things. But with things like chain of thought reasoning, with all these other ways that we can prompt and code in what these LLMs can do to actually get them to do real work, they can do real meaningful work that we currently rely on people for. So they can do thought labor. Not necessarily saying they're going to be researching, coming up with new research or really innovative stuff, but just a lot of the stuff that we have to do now, which is pattern matching, which is interpretation, which is summarization, which is annotation. And, your job may be more complex than this, but maybe other people's are, more squarely in the firing line. And, it's likely to continue to get cheaper to automate more thought labor jobs where we can use more prompts, go do more engineering, kind of, attack those next scales up as, the LLMs get more cost effective. So AI agents are the killer app. We can basically take what we're doing now, replace it with a solution which is, costs at 10% of the price to operate, and we get a huge amount of benefit. And businesses that don't do that, they're going to struggle, So, I think the thing is like, for anybody who's even closely related to the space right now, it's so easy to see that this is the big trend that you should be involved in if you're thinking about being involved in it, because it is going to change the way we do business fundamentally. And I think the exam question then is, what does your business look like in a world of AI agents? So, like we say, mobile was probably in some ways a bit harder to imagine because it was changing the way we interact with businesses. But you can see that with the move to mobile, so many of the old businesses kind of became smaller or got outpaced with a big global player that just was like mobile first or all this sort of stuff. And basically, if companies are slow or hesitant to adopt this, AI agent tech, they're going to get left behind. And so I think the real thing is it's this new world. The world's experts are 1 year ahead of you. So, it's not that hard to get in, catch up, and be a leader in the space. Cool. But yeah, AI agents of the future, the killer app for 2024. Check them out.